Hi everyone, my name is Benjamin, and in today's video I will show you how you can interact with and retrieve data via our historical RPC endpoints. So we are going to talk about how to use these historical supported RPC methods, what the benefits are and when to use them, and eventually how we can apply this when creating our own simple wallet explorer. And on top of that, all the code will be available for download via our GitHub repository. For more information, you can always visit our official documentation or join our great Discord community. Both links will be in the description, and with that said, let's get started. Alright, so before we jump into the actual code examples, let's check out the documentation first. You can do that by going to docs.solanavibestation.com, and then under API docs you will see historical. And if you click on overview, you will get an overview of all the available historical supported RPC methods. And you can also see that all the data or all the historical data is stored on our own servers, which are hosted on-prem. And that will provide our users the fastest possible retrieval times if it comes to that historical data. And that is because we are not dependent on any external cloud dependencies. Now here you can see the overview of all the methods that are available, and these might look familiar because they are also available via the regular HTTP methods. The only difference is that we have a historical endpoint available for these RPC methods. And here we can see how we can use it. We can interact with them the same way that we do with the regular HTTP methods. The only thing that we need to do is add the historical parameter, so /historical. We also need to make sure that we provide a finalized commitment level, because if we look for data with a lower commitment level, we will get an error. And here we have an example URL, so we can just use our RPC URL and add the /historical. And we can also add our API key if you have a subscription. Now we can also see if the data comes from this historical endpoint by checking the header x historical data. And if that is true, then we know that we did everything correct. Now finally, it always takes a few seconds before the data is finalized and available via the historical endpoints. There is always a small delay before the data is queryable. Now we can always use the regular HTTP methods because that data is available for us 12 to 24 hours depending on what node we are routed to. Now this also means that the regular HTTP methods are quite fast because they don't have to deal with all that historical data that we can query after this amount of time using the historical endpoints. We can query recent data using the regular HTTP methods, which are really fast because all that historical data is available to us via the historical endpoints. So now that we know how to use it and what methods are available to us, we are going to build a small wallet explorer where we will connect our wallet, and we are going to check out the signatures using our regular HTTP endpoints and the historical endpoints. So if that sounds interesting, like the video, and with that said, let's check it out. Alright, so in order to test these historical endpoints, we are going to build a simple wallet explorer. And that app will allow us to connect our wallet and check out transactions, both recent ones and historical ones. We are going to build this app using Next.js. And if you go to the Solana documentation and you scroll down a bit, you will see frontend. And if you click on frontend and then Next.js Solana Kit, you will find a guide that will allow you to set up a simple project. This project will allow you to connect a wallet, send a memo transaction, sign it, and then check it out on the Live Explorer. So this is the application that we are going to use to add our additional functionality to check out these old and new transactions. Now, in order to set up this Next.js project, what you can do is follow these steps here below. And you will have to create a new project using ShadCN. And ShadCN is just a component library that allows you to own all these components. Now, once you created that new project, you have to cd into that project folder and install some of these UI components. As you can see, we will need a button, a drop-down menu, and a avatar. And we will also have to install some Solana dependencies. And these are used to connect our wallet, of course, send transactions, and investigate these transactions. Now you also have to create some new files, and the files that you will have to create are mentioned here below. So you will have to create a file called Solana Provider, and this file contains all the logic that takes care of your entire wallet state throughout the application. So you create these files and then you add the components or the content that you see here. You will also have to update the layout, and it describes here exactly what you need to do. So you have to go to the layout file and then just copy this contents here and paste it in that file. You will have to create a wallet connect button, of course, and once once you created this file, you have to add these contents in there. You also have to create a send transaction component. You do the same here. You create that file, add the contents in there and save it. Eventually you will have to update the app page, and that is easy because the app page is also already there, and you just paste these components in there, and eventually you can test your application by running the npm run dev command, and that will start up your application. And if everything went well, then you'll end up with an application that looks similar to this. And again, all the code is available within our code repository, so if you don't want to do this yourself, that's fine. You can download it. The link will be in the description, and then you can follow along that way as well. Now, if everything went well and you followed the guide or you downloaded the code, what you can do is open a terminal, new terminal, and also we can start our application. So we can type npm run dev, and that also should start up the application for us, just as the guide mentioned. Now we have of course additional functionality that we will look at in a minute, but we can check out if our app actually works. So if we go back to our browser, that will spin up our application. And you can see here that we have the same interface where we can connect our wallet, and we can also send that memo transaction, just as it mentions in the guide. And we have the additional functionality here to check out our confirmed transactions and our finalized transactions, or our recent ones and the historical ones. And this is the component that we are going to build. So as you can see here, we can connect our wallet and we can also disconnect it. And then it will just say to connect our wallet, both for the confirmed and the finalized transactions. So once we connect our wallet, you can see we can send a memo, and we can also check out the old transactions and the recent confirmed transactions. We can also disconnect. So if we log into our Phantom and we change our wallet, what we can do here is, for example, check this wallet out. If we then connect it once again, you will see that we also have these other transactions here. And we can refresh it because our wallet stays connected. And we also have a refresh button. So that's what we are going to make. All right, so if we go back to our code, what we will do is move this terminal into the editor area so we can switch between all the tabs really easy, and we can leave this running. And if you click on README, here you can see all the additions that we made on top of the original documentation from Solana. The first thing that we did is create a transaction card component under components and then tx card. And this file holds all the logic that will display these transactions. So if we go back to our application, you can see here confirmed and finalized transactions. And this component lives in that file here, the txcard.tsx. Now we also added server actions to fetch these historical transactions and our recent transactions, and that you can find under app server transactions.tsx. If we go to app server transactions.tsx, and here you can see that we have all the logic to get signatures, historical signatures, transactions, and historical transactions. And these functions we are going to consume from within this txcard component. So we will be able to get the signatures from the wallet that is connected, and then based on the signatures, we will be able to get the actual transaction information by using these functions here in that transactions.ts file. And besides that, we also added some extra functionality to make sure that our wallet stays connected. So as you saw earlier, if we refresh that page, our wallet stays connected, and the official documentation, it doesn't do that. Once you refresh your page, the wallet is disconnected. So these are the changes that we made on top of the actual project that we created from the Solana documentation. Alright, so before we going to check out the code from our own implementations, let's check out the documentation really quick first. So if we go to docs.solanavibestation.com, and then once again under API docs historical, you can see the overview of the RPC methods that are available. Now for our application, we are going to use the get signatures for address because we are going to connect our wallet. And then based on that RPC method, we are going to get all these signatures back for that wallet. And here you can see what it is. So it returns the signatures for confirmed transactions that include the given address in their account keys list. So as you can see here, this is how we can actually query for that historical data. And what we will do is use this RPC method. So we are going to create a post request, and then we are going to provide our wallet address here in the parameters. And you can see there is other options, like we can set a limit, and we can also ask it to return the results in a reversed order. But what we will get back eventually is a list of all these signatures that has to do with that wallet wallet that we connected with. Now, as you can see, this method is quite similar to the method under the HTTP methods, and also that method we are going to use to see if we can query that data using the regular HTTP method. And if it's too old, the transaction is older than 12 or 24 hours, depending on the node that we are routed to, then we will be able to use the get signatures for address method using the historical endpoint. So that is what we are going to do. We are going to use the get signatures for address method using the historical endpoint and the regular one. And then we are going to see what we get back. Now, once we get these signatures, the next method that we are going to use is a get transaction. And what get transaction does, as it says here, returns the transaction details for a confirmed signature or confirmed transaction signature. So we're going to use this post request here, as you can see, so it looks similar, but this time we are going to provide the signature that we queried. So once we have all these signatures in our application, we will be able to click on it, and then based on this request, we will get back all the transaction details, and then some of these transaction details we are going to display within our application. Now, also here, this method is available via the HTTP methods, and that we will also check out. So once we click on that signature in our application, we are going to try and fetch the transaction details using the historical one and the one via the HTTP method. So it's the same method, but we are going to use the historical endpoint and the non-historical endpoint and see if we get it back or not. So now that we know which methods we are going to use, let's check out our own implementation and see if we can get it to work. Alright, so let's have a look at our app real quick once again, and you can see that this is the component that we added ourselves. So once our wallet is connected, we can see the confirmed transactions and the finalized transactions, or the transactions queried using the regular endpoints and the transactions queried using the historical endpoints. And then here you can see that we have all these signatures that have been returned, and once we click on it, we get a sheet with some transaction details. So that is the logic that we added on top of the app that we created with the instructions from Solana. So let's start by looking at the TX card. And this once again holds all the logic from the component that we see here. So once this component mounts or loads, what we will do is set a state for the current date. So every time we refresh this page, we can see when it was refreshed the last time. And then we are also going to get the state of our wallet, and that we can do by checking the use Solana method. And this was imported via the Solana provider, which was created via the documentation from Solana. And this points to the components Solana provider file. And then we can extract the actual connection state to see if it is connected and also if a account is selected. And based on that selected account, we can derive the wallet address and we store the wallet address. Next, we are going to create some states to store our signatures in. So as you can see here, we will have a state that will hold our historical signatures and our recent signatures. And we do the same for the transactions. So once we have the signatures, we can click on one of them, and then we will store these transaction details in the states that we create for them. And also that we will try to do via the historical endpoint and the non-historical endpoint, and we store it within these states. And then we also have a sheet, and as you saw earlier, the sheet is when we click on one of these transactions, it will open here on the right. And what we will try to do is check that state or keep track of that state of that sheet to see if it is open or closed. Then below we have all the logic to fetch our signatures and our transactions, and we will look at that in a minute. The first thing that we will check out is this use effect hook. And this use effect hook is triggered every time the component mounts or the page loads, and also if any of the provided values change here. So if a wallet is connected or disconnected or the wallet address changes, then this hook will be triggered. And as you can see here, what we will trigger is check the initial status, which is pointing to this function here, and we will also set the state in our current date state. So remember the one that we created here on top to hold the date or the time when it was last refreshed, that we will also set here once this use effect hook runs. Now check initial status. What that will do is just check if a wallet is connected, if we have a wallet address, and then it will load the signatures. And this load signatures function is declared here on top. So if we look at that, what this will do once again is check if the wallet is connected. If we have a wallet address, it will send a toast notification to let us know that we are checking the signatures, and then we are going to fetch the signatures. And for that, we have two functions, the get signatures function and the get historical signatures function. And that is pointing to these two functions here on top. And that will return to us all the signatures that are related to the wallet. So if we look at these two functions here, what they will do is fetch the signatures based on the wallet address, and the wallet address we derived, remember, from the use Solana method that provides the state of our wallet. So we provide that wallet address here, and then we use the select signatures function and select historical signatures function, which are declared here in that server side file. So if we click on transactions, or we can also just click on select signatures, then we will go to that file here, transactions.ts. Now, if we look at the first function, which is quite similar to the historical one, but we will look at that in a minute. What we do here first is create our RPC endpoint URL. And remember, we specify here the URL that we want to use. And if you have a key, you can also provide that here. And then we are going to build that URL. If we have a URL and we have a key, then we are going to, of course, use that. If that is not provided, then we will use the public RPC from Solana Vibe Station. Now you can see here that this is not the historical one. And what we are going to do here is take that RPC URL and do a post request using Axios. And Axios is just a fancy fetch library that we can use to do that post request. Remember, if we go back to the documentation, if we look at the get signatures for address, this is the post request that we are going to do. Now, of course, the first function that we are looking at is not the historical, but the one here under HTTP methods. And then if we expand this as well, we can look for the get signatures from address. And this is the request that we are going to make. This is the endpoint URL that we will have to use, or the one that we set. And this is the body that we will have to provide. So if we go back to our code, that is exactly what we do here. We use our RPC URL without the historical parameter. And that is the body that we are going to use to do that request using the method get signatures from address. And here we provide the wallet that was provided to us via a parameter. And again, this function we consume via the txcard file here. So what this will do is send us a response. And in that response, we're also going to check if that header, the X historical data, is present. Remember, if that is true, then we know that we are querying a historical endpoint. So in this case, it should be false, or we expect it to be false. However, we are also going to return that back to our txcard file. And of course, also the signature result. Now we have types for this, as you can see here. The post request will be of type signature response, and all the types are here declared on top, as you can see. That's how it should look like. And then we have signature result, and this is the result that we expect. And then eventually we are going to return that, and here you can see that we will return that signature result, and also if it is historical. So we are quite type safe, and we know what we are going to return and what we can expect in our txcard. Now we do the exact same thing for the historical signatures. However, as you can see here, once we are building that RPC endpoint, we provide the /historical endpoint or parameter here. And if we don't provide the API key or the RPC URL that we set here on top, we are going to fall back on the public one. But also here we are going to provide the historical parameter. And also here we are doing this post request, and we are going to use the get signatures for address method. And here we will of course also provide our wallet. And here, as I showed you earlier, we can say if we want these signatures in a reversed order or not. And we can also specify a limit. And for now we are just specify 10 as the limit. So we don't go all the way back in time, but we are going to return the 10 last signatures. And also here we are going to check if that X historical data header is present. And this time we expect it to be true. And then we also going to return that to our txcard file here. So if we go back at that, what we do here is return these signatures. So eventually we are going to store these signatures in that constant. And if any signatures are found or a array is returned that is greater than 0, we are going to set these signatures in our states. Remember the set6 state and the set H6 state. So these states, remember, they are declared here on top and they are loaded once the component is mounted. So that's what we do here. And if we go back to our application, so that is what happens when we refresh this page. As you can see here, now this load signatures function is triggered and we are getting the recent transactions, but none are returned, and we are getting the historical transactions, and a few are returned, but there should be no more than 10 because we set that limit. And I showed it earlier. Once you click on a transaction, you will get these transactions transaction details, or once you click on a signature better, you will get these transaction details. So now that we know how we load our signatures, we can move on and check our actual components. So we have the two tabs, the confirmed transactions and the finalized transactions. That's what we can see here, confirmed and finalized transactions. And if we look at that, what we do here is create that button or the refresh. So once again, if we click on that refresh button that you see here, that small refresh button, what we will do is trigger the function load signatures once again. And load signatures is triggered also once the use effect hook runs, but we can also trigger it manually. Now next, we will check if our wallet is connected. If the wallet is not connected, we will display a message saying to connect a wallet in order to see transactions. And then we are going to check these states, like the 6 states, to see if we have any signatures returned. And if none are returned, then we will also display a message that there are no confirmed transactions. However, if we have transactions in our state, we are going to loop through them, and then we are going to create a nice card. As you can see here, that card is what we are going to create, and that's what we do here. And we have a on-click statement, so if we click on that card, we are going to load the transactions. Now we are going to do the exact same for the historical transactions, so that's what we are doing here. So if our wallet is not connected, we provide a message like, hey, you need to connect a wallet. If there are no historical transactions within that H6 state, then we will also provide a message that there were no historical transactions. However, if there are transactions, then we are also going to loop through them, create that nice card, and also here have that on-click event if we click on it to load the transactions. And if we look at the load transactions function that is also declared here on top, what we will do is first empty our states for our transactions, the one that we declared here on top, because we want to make sure that we are pulling in the latest transaction details. We are going to open our sheet, remember that side panel, and then we are going to get these transactions using the transaction or get transaction function and get historical transaction function. And here we provide the signature, and these two functions are declared here on top, and in turn they also point to that transaction.ts file. So if we look at one of these functions here, it expects that signature, and we are going to do the exact same thing here. We are going to build our RPC endpoint without the historical parameter, and then we are going to send that post request using the method get transaction. And if we go back to the documentation real quick and we scroll down, we have that here, the get transaction. So this is the method that we are going to use, and this is the post request that we have to send. If we go back to the code, that is exactly what we do. We create that post request here, and we set the method to get transaction, and we provided that signature and also some other information like the commitment. Now, if we are not using the historical parameter, we can set the commitment to confirmed. Remember, if we are going to use the historical, we can only fetch data once it's finalized. And if we have a look at the select historical transaction function here, that is what we are going to do here. So of course, we create our RPC URL, including the /historical parameter, and we are also creating that post request here. And the only difference here is that we don't specify the commitment level because we want to fall back on that finalized commitment level that is required if we try to select this historical data, and that's what we do here. Now for both of these functions, we also check the X historical data header because we want to make sure that we are querying from the right endpoint, and in this case it should be true, and for the previous function we expect it to be false. And also we are going to return that data back to our TX card, and also for that we have types that we have declared here on top to know exactly what data we are returning. So back to the TX card component, once we get that transaction details, we are going to store that into this constants and then also store that into the states that we created here earlier. Remember, so this will hold our states or our values from these transactions that we just queried. So if we go back to our app, once we click on any card within our app, what that will do is go and fetch these transaction details or this signature and then display them here on the side. As you can see, these are all historical signatures. So if we click on them, we only expect historical transaction details. If we have a recent transaction and we can create one, so if we send a memo, for example, this is our first memo of the day, you will see that we are now going to create a recent transaction. So if we send that, and of course we have to sign it, you will see that now this transaction, if we refresh it, is available here. However, it is not available within the finalized transactions, and that is because it has a small delay before it is finalized and available via our finalized transaction. So now that we refreshed it, you see it is finalized. So if we refresh our page, you should see we have it still on the confirmed transactions here, but we also see it on our finalized transactions. transactions. And if we click on it, we get both the confirmed transaction details from the non-historical endpoint and from the historical endpoint. And that is because we are within these 12 to 24 hours that these transactions are available on the regular endpoint. So if we click on this, also here we see the historical or the non-historical and the historical endpoints returning that information. However, if we look at a older signature, here we only get back the historical data. And that is because that signature is no longer available via the regular endpoint and only available via the actual historical endpoint. So now we covered how we can actually check these signatures, and once we have the signatures, how we can get the transaction details. And again, all the code is available via our Git repository, so if you don't want to type all of this yourself, you can always download it and play around with it. So that's how the endpoints work for both the regular one and the historical one. You just have to remember that these methods are available both via the non-historical endpoints and also via the historical endpoints, and they are the same methods. The only difference is that we query them via a different endpoint. And also the historical data we can only query once it is finalized, and that's why we had that small delay, remember? So we send that memo transaction. Once it is confirmed, it is available via the regular endpoint. However, it is only available via the historical endpoint once it was finalized. So that's the main takeaway from this historical and the regular endpoints. Now that you know how they work, what methods you can consume, and you also have an example of a code base that you can download via our Git repository, you can play around with it, see how it works. And if you have any questions, as always, check out the official documentation or jump into our great Discord community server. Both links will be in the description. And with that said, I hope you think it was interesting, and I'll see you in the next one.